Okay, so I turned the BiTT transformer into a inverter. What I did is the primary has 16 parallel lines, so I paralleled all 16 in and out, so I have maximum low impedance. And that is being driven by a 12-volt battery, which is down to about 11 volts. And I have a Hall effect here and another one here. One Hall effect turns these on simultaneously. The other one turns these on simultaneously, and they send DC one way and then DC the other way, so creating AC from DC. So it's an inverter, and it's stepping up to about 99 volts if I put a voltmeter across here. Right now I have a 110 ohm resistor there. Here's the amps it's drawing from the battery. It's quite a bit of amps. 4 amps coming out of this. This battery is supplying juice to the pulse width modulator, the little tiny motor in here from a computer fan, and also the relay, trigger side of the relay. All 4 relays get the power from here. This is about 50 milliamps. If I turn it up really fast, it draws all the way up to 100 milliamps. The motor, pulse width modulator, also the Hall effects, and the relay. So this is kind of the triggering supply battery. And this is the load battery, I guess you'd call it, I don't know. But so this goes in there, and I got an H bridge. And let's see what we get out of the 110 ohm resistor. This is not so efficient, but it's working. I have the secondaries hooked up in series as usual, and I just did a 20 ohm resistor, and it had 11 volts across it, so it's about 6 watts being produced across a resistor. A 20 ohm resistor. And so that's not very good efficiency. That's like 48 volts in. That's the amp draw from the battery. Maybe 44, maybe only 40, because this battery's almost discharged. Just a sec, I'm going to check the voltages. Okay, across the load resistor of 110 ohms is that much voltage. 33 point whatever, 5, 6, 2. It's about 33 volts across 110.7 ohm resistor. Okay, 1 minute. Okay, across the battery powering the whole schmeal is 11.2 volts. So it's around 44 watts it's drawing, according to the meters. The resistor is getting quite hot. It's at 33 volts across it. And what else could there be? Okay, let's turn it up a little bit. I'm guessing this is about 900 RPM. It's about halfway up to 60 hertz. About 30 hertz. I don't have an RPM meter. I'm going to have to get a new one. But if this is going 1800 RPM, it's going to be 60 hertz. As I have trigger magnets on the rim of this little disc at 180 degrees and Hall effect and a Hall effect at 90 degrees. One Hall effect triggers these and the other one triggers these. So it's kind of like a 4-pole little motor down there. 4-pole AC motor. So I'm going to turn up, I'm going to put the voltmeter back on the resistor and turn up the frequency. Okay, voltmeters across the 110 ohm resistor. I have about 33 volts again. And I'm going to turn up pulse width modulator, which decides the speed of this disc spinning. So this is like a variable frequency drive. Okay, here we go. Just turn it up a little bit. It's up a little bit. Oh, that's nice. It goes up to almost 45 volts. It only goes so fast. $39. I'm turning it up and up. Right about here is its maximum speed. If I turn it up any more, the voltage drops. So I guess maybe these relays can't keep up with the frequency or something. So I'm going to leave it at, like, say 40 volts across that resistor. Oops. I brought it up too high and it drops. I'm turning it down now. I'm just going to hold it right here. I remember when I ran a rotoverter motor with this, I could only go about 11 or 1200 RPM. And then it would kind of cut out. I'm going to guess these relays are too slow. Solid state MOSFET relays, 20 amps, they say, 480 volts DC. And I don't believe that 480 volts. Okay, so I got those going. Here we go. We're 42 volts across this. And what am I going to do? I'm going to check to see what the draw is now. Hold on a sec. Okay, the draw's 5.8 amps now. That's a lot. Coming from that battery. So when I turned up the frequency, the draw went up quite a bit. Anyways, got it working. This is my first try running it. Very excessive draw happening. A regular inverter would probably be drawn about 2 amps, and it would be making 120 volts for sure. Anyways, it's an experiment. I am using the BiTT transformer as a step-up transformer inside an inverter, so that's good. Okay, thanks for watching.